First, in cryptocurrency tracking, after a quick understanding of the specifics of a cryptocurrency wallet address user, we will go over how to identify the transaction information provided on blockchain.com and etherscan.com to understand the transaction history of cryptocurrency. After reviewing the cryptocurrency transaction details like so, we will learn how to utilize the exchange office and OSINT information to specify cryptocurrency wallet address users.
Specifying cryptocurrency wallet address user 1.
A simple summary of the cryptocurrency tracking process is composed of the process of checking the address of the other person in the cryptocurrency transaction amount of the cryptocurrency wallet or address of the person targeted for investigation, and the process of specifying the actual user of the cryptocurrency wallet or address used by the person targeted for investigation.
Specifying cryptocurrency wallet address user 2. View transaction history on Bitcoin, Ethereum.
Anyone can check the transaction history of cryptocurrency. There are various websites on the internet that provide services to search cryptocurrency transaction details. First, let's check the transaction history on blockchain.com, one of the most popular web pages to search Bitcoin transaction information. Most cryptocurrency transaction search sites can check the time of the transaction, the Bitcoin address of the transaction party, and the transaction volume by searching the TXID, which is a unique ID of a cryptocurrency transaction. You can also search for a specific Bitcoin address and view all the Bitcoin transactions of that address. You can easily check for the information by accessing the address on blockchain.com and entering the TXID or Bitcoin address in the search bar. Let's check a simple individual Bitcoin transaction history on blockchain.com. This data is a simple Bitcoin transaction history retrieved on blockchain.com. When we look at this data, number 1 is the transaction ID, TXID, which is the unique ID of the transaction. Number 2 is the address of the sender of the Bitcoin in this transaction, and the amount that was sent. And numbers 3 and 4 are the address of the recipient of the Bitcoin in this transaction and the amount received. To simplify this data, the Bitcoin address of sent 0.002341 Bitcoin to address and 0.00103 Bitcoin to address. But I think that the Bitcoin address owner of this transaction sent 0.00103 Bitcoin to address and took back the remaining 0.002341 Bitcoin. In other words, the original Bitcoin owner only sent 0.002341 Bitcoin out of 0.003479 Bitcoin to address and kept the remaining 0.00103 Bitcoin for themselves. I will slowly explain the reason why I came to this conclusion. Last time, we learned that more than one address can be generated for a cryptocurrency wallet. Now, let's learn more specifically about managing addresses in a cryptocurrency wallet. The most basic structure is the non-deterministic wallet. In this wallet, cryptocurrency addresses are generated using different personal keys. In this case, there is the difficulty of needing to manage as many personal keys as there are addresses. Next type is deterministic wallet. After deriving a personal key through the initial specific seed, the key information is combined with data such as an index number of chain code to generate the cryptocurrency address again. In this case, there is an advantage that all wallet addresses can be managed with just the initial seed or personal key. But the security of the initial seed or personal key becomes as important. Lastly, the most advanced and most used cryptocurrency wallet is the HD wallet, which is an acronym for Hierarchical Decision Wallet. Like the hierarchical wallet before, it derives the personal key through the initial seed value, and then it generates various addresses by calculating the keys of the next generation through a tree structure. In this format, it is not only easy to manage various wallet addresses, but also has the advantage that wallet address generation cannot be predicted from the outside. It would be nice to be able to explain the specific generation principles of cryptocurrency wallets, but it is difficult to explain in detail with a case that is limited. However, we should note that there are multiple addresses in a cryptocurrency wallet, and that all addresses can be managed through a single personal key. In order to understand the transaction details of the Bitcoin network, it is necessary to understand the concept of UTXO, as well as the wallet structure. UXTO stands for Unspent Transaction Output. Bitcoin does not store the amount of Bitcoin stored in each address separately like a bank account does. To know the amount of Bitcoin stored in each address without the UTXO, you have to check the balance by looking at all the transaction histories to calculate the deposit and withdrawal amounts of the specific address. However, as the Bitcoin network grows and blockchain volume increases, it inevitably becomes extremely inefficient to check all the details of the blockchain to find the balance of a specific address. UTXO was created to improve these shortcomings. In the Bitcoin network, Bitcoin that is stored and not sent to another person, that is, unspent Bitcoin, is separately stored so that when checking the Bitcoin balance of a specific Bitcoin address, it can search for the unused balance data. UTXO is to check the unused balance information. Metaphorically speaking, UTXO can be seen as a sealed envelope with Bitcoins in it. To explain the specific transaction situation, I will use a simple example to explain. Let's assume that you own one Bitcoin at address A among various addresses in the Bitcoin Alpha wallet, and that one Bitcoin is stored through one UTXO. Now, I will explain the process of transferring 0.5 Bitcoin from the Bitcoin in address A to an address in someone else's wallet. From the UTXO that contains the 1 Bitcoin of address A, take out 0.5 Bitcoin and put the 0.5 Bitcoin back into a new UTXO. Then, it goes through the process of sending this UTXO to address B managed by the beta wallet. Then, it is easy to think that the remaining 0.5 Bitcoin will be in the UTXO where 1 Bitcoin was originally stored in address A. But once Bitcoin is taken out of a UTXO, that UTXO is destroyed. It's like tearing a sealed envelope open and taking the money from it. That envelope cannot be used again. In other words, once a Bitcoin stored in UTXO is sent, that UTXO can no longer be used. Now, after sending 0.5 Bitcoin to address B, the remaining 0.5 Bitcoin needs to be placed in a new UTXO and be returned to the Bitcoin address of the Alpha wallet. At this time, the 0.5 Bitcoin will be received by another address, address A, among the numerous addresses of Alpha wallet. It is so that this format needs to be in place so that it becomes difficult to check the Bitcoin transaction from the outside, thereby protecting the individual's privacy. We are back to the Bitcoin transaction history again. When we look at this transaction, you can see that the UTXO that contained 0.003469 Bitcoin in address was destroyed, and 0.002341 Bitcoin of the UTXO was sent to wallet, and 0.00103 Bitcoin of the UTXO was sent to wallet. So, in this transaction, how can we determine that address is in the same wallet as address? We learned last time that there are 3 types of address generation algorithms in Bitcoin. Let's refer to the material from last time briefly. There are 3 types of address generation method for Bitcoin, and based on each address generation method, the first letter of the address is either 1, 3, or BC1. If we come back to the Bitcoin transaction data we were looking at, in this transaction, the AND wallets start with BC1. So we know that these addresses were generated through the Behu32 algorithm. The address starts with 3, so we know this address was generated using the P2SH method. Normally, multiple Bitcoin addresses generated from one wallet are generated using the same algorithm. So it can be deduced that an addresses generated using the Behu32 algorithm in this transaction are the same wallet, and that address is of a different wallet. Not all transactions occur as transferring transactions and balance transactions. In this case, in order to send the Bitcoin in the UTXO to all different addresses, the Bitcoin in the UTXO was taken out, and all the Bitcoins were sent to different addresses by paying a fee. In this transaction, one UTXO with more than 6 Bitcoins stored at one address was destroyed, and multiple UTXOs were created using those Bitcoin, and then they were sent to multiple addresses. In this transaction, the balance stored in 3 addresses was combined and transferred to another address. From the transaction information, we can know that the 3 addresses on the left are actually addresses managed by one wallet. Ethereum also allows you to view transaction information on the web. Similar to blockchain.com, you can check Ethereum transaction information on Etherscan, one of the most popular sites for viewing Ethereum transaction information, through the transaction ID and address of the Ethereum transaction. For Ethereum, it is more convenient to check for the transaction information compared to Bitcoin. Ethereum does not use the concept of UTXO and has a separate space to store the balance information of Ethereum addresses on the Ethereum network. Therefore, Ethereum transactions are clearly divided into receiver, sender, and transaction time payment. There is no balance transaction or transaction formation that uses multiple UTXOs. The data on the screen now is an Ethereum transaction created by DApp activity. Last time, we learned about the EVM that works as a virtual computer in the Ethereum network. And through it, you can create a type of app called a DApp through smart contract. Since the usage history using these smart contracts is also stored inside the Ethereum block, it can be seen when we search for Ethereum transaction information of a specific address through Etherscan. The movement of these DApps can be distinguished through transaction action. Therefore, if you want to check only the Ethereum movement history of a certain address, it is necessary to distinguish through transaction action, which is the transaction activity classification, whether this transaction is generated through DApp activity or Ethereum transaction.
Specify cryptocurrency wallet address user 3.
So far, we learned about ways to check the transaction information of cryptocurrencies. Now, we will learn about ways to specify the user of the cryptocurrency address. In fact, it's impossible to classify the users of all cryptocurrency addresses. However, it is possible possible to check the other addresses that has had transactions with the cryptocurrency address targeted for investigation. Among the addresses with these transactions, if it includes a cryptocurrency exchange office or if the user is verified using the OSINT information, the user of the cryptocurrency targeted for investigation can be specified through the user who had a transaction with the cryptocurrency address targeted for investigation. Cryptocurrency exchange offices of most countries must comply with the anti-money laundering standard. Under AML, suspicious transactions and high-price transactions must be reported, and it must satisfy various conditions such as checking the exchange office customer information. Therefore, if the person targeted for investigation moved their cryptocurrency through a cryptocurrency exchange office operated in most countries, the investigating agency can request for the recipient information from the exchange office through the cryptocurrency address of the exchange office and the transaction history of that cryptocurrency. But unfortunately, it is not easy to check the cryptocurrency exchange office address. For Ethereum, it is a little bit easier since on Etherscan, the address used at the exchange office is shown as the name of the exchange office. If you look at the transactions from the example data, if the address of a popular exchange office, OKX, was used, the address of the sender is shown as the name of the exchange office. Therefore, for Ethereum, exchange office transactions of the cryptocurrency wallet or address targeted for investigations can be checked relatively easily. However, it is hard to receive these types of services for free with Bitcoin. The cryptocurrency exchange offices do not disclose their addresses for security reasons. However, that does not mean there is no technique to check the address of cryptocurrency exchange offices. A representative technique to verify a cryptocurrency exchange office address is the dusting technique. This technique repeats transactions of very small amounts at the cryptocurrency exchange offices and uses blockchain to analyze the transaction and specify the address of the cryptocurrency exchange office. The analysis of all the addresses of these cryptocurrency exchanges can be verified through long-term research by an expert group. Virtual asset analysis companies find the wallet address of the cryptocurrency exchange offices with their own special techniques and provide an analysis tool for the exchange office address information and cryptocurrency movement as a paid service. The information of the cryptocurrency owner can be verified through OSINT as well. For addresses with a lot of cryptocurrency or cryptocurrency addresses used for crime, various information can be found through OSINT. Also, for famous addresses of cryptocurrency exchange offices, information on which cryptocurrency exchange office was used can be found by searching. We can also use the OSINT search technique and search tool that we learned before to collect cryptocurrency OSINT.
Summary. Let's take a look at the summary of this session.